Welcome back, everyone. Now we get into ACLs. Let's first talk about a little bit about what they are, access lists, right? We have standard, extended, and now named. Yes, named. You will be creating named access lists, but again, there's only standard or extended. It's one or the other. Because these are considered numbered access lists because you actually put a number that lets the iOS know, hey, this is the access list I'm about to create. All right. If you put it through 1 through 99, you're going to create a standard access list. If you put it 100 through 199, the iOS knows you're going to do an extended access list. Now, benefits or disadvantages to one or the other. Standard access lists are very limited because you can only use source addresses and you need to place it nearest the destination because all you can say is, hey, I'm denying myself from accessing that over there. Well, you can say that, but you can't write that. You will be access list 1, deny host 1111. Okay, you're denying that host, but you're not telling me anything else. So that's why you got to put it nearest the destination. Nearest the destination. So if it's 3 routers away, 5 routers away, whatever it is, you got to put it way over there. You create it and you apply it over there. All right, where an extended access list, you do it nearest the source because they're more flexible. You can go ahead and use source addresses, destination addresses. You can use protocols and port numbers. You can be very specific as to what exactly it is that you are permitting or denying. So you can place them nearest the source. So if you want to place them on the gateway, on the interface of your gateway going in, I mean, the router doesn't even have to process that information. You're being denied at that point. Okay? The named is the same thing. The only difference is when you're doing a numbered access list, you're starting it off with access list, then the number. With a named access list, you're going to start IP access list, and then you go from there. All right, so that's the only difference, but we will be doing labs on all 3 of these. All right, all 3 categories, right? Standard, extended, and then named. All right, so we'll be learning how to do those. All right, now there's rules. There's rules to ACLs. You're going to have 1 access list per protocol, per interface, per direction, meaning either in or out. You can't have 2 ins, 2 outs. It's one direction. So 1 access list per protocol, per interface, per direction. That's it. Now, access lists can be several lines long. You don't have to have, just 2 lines or 3 lines. It could be 100 lines long. It doesn't matter. But that is a group. Okay, you go access list. Let's say we're doing a numbered access list 100. Then you have access list 100 1,000 times. That's fine. Okay, that's fine. That's 1 access list. Right now, what you need to remember is you have an implicit deny, meaning an invisible deny at the end of every access list. What does that mean? That there's an invisible deny everything, both on a standard, extended, and named, whatever. All right, but there is an implicit deny. You need to remember that because when being tested, all right, they may put everything deny. If you start an access list with a deny statement, you got to make sure that it ends with a permit statement. If not, you're going to deny everything. So because access lists are read from top to bottom, 1 line at a time until it makes a match. So if there's deny, you leave it like that, then everything is denied. So if you have a deny, permit, then permit any, if that's what you're trying to do. So it's more of a logical thing. You have to think about exactly what you're doing. And Cisco is really doing a good job of creating these topologies, making you think not only the type of access list that you're doing, but where you should apply this particular access list based on the topology that you have in front of you. So when you go take your certification exam, and I'm telling you now, pay attention to your topology. Take a look at it, see what they want you to do. There'll be clues as to what type of access list you're going to create, and then where am I going to apply it? All right, even though I'm telling you that destination is nearing the source, that's a standard is nearest the destination, and extended is nearest the source. You got to say, I know the book said this, and Laz told me to do this, but based on my design, I need to do it here. Okay, so Cisco is making you think. So be very careful when doing this because simulations do hold weight. All right, so those are the rules. All right, now they want you to know how to create remarks. And we're going to do all these labs. And it's fine. That's fine. You make a remark and an access list. All right, so you can be very descriptive about what that access list does. It's a comment. You can put it in the very top. You can put it in the middle. You can put it at the end. It doesn't matter. It's not going to get read. This is for you. So you know what this access list is. It's a comment that you can create. So imagine if you create a named access list that you're giving it an actual name. Hey, block whatever, or you can't have spaces. It's all underscores. Block underscore network underscore HR. So you have that. Okay, so you know what that is. It's no longer a number. And on top of that, you can create a remark so you can be even more specific. Also, we're going to do ACLs. All right, the way you apply ACLs, is to go to the interface and put IP access group, whatever it is, 1, 100, or if it's a name, block, the network HR, whatever I said, okay? And there's also an IP access class. Now, we're going to get into this, and I want to give the surprise away once we get into the labs, but IP access class is basically used for your Telnet lines, and you'll see once we get into the lab. So this is what access lists are for. They're to control traffic, control, permit or deny, just like we said in VLANs, right? But now we have intra-VLAN configuration. We can go and contact all the networks we want, but we need to be able to deny certain networks or certain networks through certain ports. So this is what access list does. Yes, you have firewalls. Yes, you have Active Directory that can do GPOs. You have a million things, but this is not a Microsoft exam, so you don't have to worry about GPOs. And you're not going to be creating firewall policies in this exam either. That exists in the real world, but what Cisco wants you to know is if you're left in the middle of the desert with a network, and this is all the tools you have is an access list, how would you use it to create and secure your network as best as possible? All right? With that said, I'll see you in the next. Welcome back, everyone. Now, we've already talked about all the different types of access lists that we're going to create. In this particular lab right here that we're going to use, we're going to create a standard access list. So you already know what they do. You know the disadvantages. You know what we need to apply them. So let's go ahead inside the lab and create our standard access list. Standard access list lab. Well, we've talked about the standard, extended, name, remarks, all that stuff. Well, we're going to go ahead and do a standard access list. As I said earlier, a standard access list is very limiting because you can only use source addresses. You can't use source and destination or protocol or port numbers like an extended access list. So you're very limited as to what you're going to do. So what we're going to do now, we're first going to check for connectivity. And let's just pick on PC2 now, because we should have everything configured. We should have connectivity across our network. Let's go ahead and ping 192.168.100.1. And we can. And let's ping 101.1. And we can. So we do have connectivity across our network. So what we're going to do is we're going to create an access list that's going to deny the 192.168.100.0 network, that entire network, to access the 192.168.102.1 host. Well, we can't do that. It's the entire network. I'm sorry. It's the 192.168. So we cannot access the whole 102 network. We can't do that. But we can't tell it that. All we can tell it, hey, we're denying the 100. That's all we can say. So that's why a standard access list is placed nearest the destination. So in this case, since we're denying this guy from this, we're going to go ahead and create and apply the access list to this particular router. So let's do so. All right, let's maximize the router. Let's do a config T. And we're going to do access list within the range of an access list. That's 1. Deny the 192.168.100.0 0.00255. So we're denying that entire network. Now remember, there's an implicit deny at the end of every access list. So if I don't put a permit statement here, it's going to deny everybody else too. So I got to come back and say, okay, access list 1 permit any. As we know already, access lists are read line per line from top to bottom. So if anybody from the 100 network comes in, is going to read the first line, says, oh, you're denied. But if somebody from the 100.2 comes in, it doesn't match the 100, so it goes to the next line. And the next line says permit any. So it will permit that one. Now, I say come in. So because this is nearest the destination, so it's got to be nearest the actual PC from the router, obviously. So we're going to go into interface F0/0, and we got to apply it. Just because you create an access list on the router doesn't mean it's doing anything. You have to now apply it. So we're going to apply the access list. IP access -group. Which group? Group 1. And which direction? Well, it's already in the router. It's trying to come out of the router. So it's going to be out. UWR. Now, how can you look to see it? You do show access list. And that's the only access list that exists on the router. How can you see which interface, or not which interface, which direction is going to? Okay, we're going to do show IP interface F0/0. Enter. And you can see that the outgoing access list 1 is set. So this is a command if you want to see which direction that you will have to do. Show IP interface and then the interface that you applied it at. All right. So let's go ahead and test it now. Let's test it. Let's first ping from PC1, which is the 101.network. We should be allowed to ping. Ping 192.168.102.1. And we can ping without an issue. Okay, lovely. Let's go to the PC0. Okay, see we've done some stuff here before. So let's ping 192.168.102.1. Destination host unreachable. So we're being denied by that access list from accessing that particular network. So, because we're trying to get out of the router. You can see I can ping the fast Ethernet interface because I'm just pinging that interface. But as soon as I try to come out of the router, it stops me because access lists work once you go through the router. So I went through that interface. I hit those lines on that access list, and the first one read it. Hey, if you're from the 100 network, you're denied. I'm sorry. Go back home. That's what a standard access list does. All right, so I'll see you outside the lab. Welcome back. That wasn't so difficult. We went ahead. We wanted to block the 100 network from accessing, or for that particular host from accessing this network, right? And we had to then, that means that we had to come all the way over here and create the access list here and then apply it to that interface. In which direction? Out. Right? Because it's already in the router. Now it's trying to get out of the router. And you saw that it worked. That it did work. But the problem with that is what we talked about previously. That you have to go up to your router. It starts processing it. Look at its writing table. Send it to the next router. He's got to process it. Send it to the next router. He's got to process it. And then finally, once it hits the interface, boom, you're denied. It's like somebody inviting you to not inviting you to a party, but you know that there's a party over there. And you just drive all the way 50 miles away, all right? And then you get to the door, you knock on the door, and you're trying to get into the house, and they say, whoa, you weren't invited, leave. So you wasted gas, time, the possibility of crashing, and then you're just getting upset at the fact that they didn't want you there. So the fact is that you're wasting bandwidth, processor usage, and all that just to get denied. That is why using standard access lists, for certain occasions, for certain things, it's not beneficial. This is where extended access lists really come into play, and they are beneficial. All right, with that said, I'll see you in the next one. Welcome back, everyone. Same lab, same exact lab, but now I'm going to contradict myself. I said earlier that standard access lists are not beneficial to a certain extent because they're not that flexible. You can only use source addresses. But we're going to configure a standard access list to permit or deny traffic. Yes, we are. So let's get inside the lab and let's see how this works. Welcome back inside the lab. Here we are again. It looks the same to me, doesn't it? But this time we're going to do something slightly different. As I already told you what we're going to do. We're going to do a standard access list, but this time we're going to use it to block or to deny or permit Telnet. At last, you said that that was impossible unless you apply it somewhere else. Each one of these particular routers is configured where you can go ahead and access it through Telnet. Let's see if that's the case. We're going to go ahead and Telnet. In this case sensitive in the command prompt. Telnet 192.168.100.254. And it's Cisco. And we're in. Enable Cisco CISCO. And we're in. No big deal, right? Exit. And we're going to check in each and every one. We want to make sure that we have access to Telnet. All right, Telnet 192.168.101.254. Cisco. Enable Cisco. And we're in the router. Let's exit. Not there. Okay, and then come here. Telnet 192.168.102.254. Cisco, EN, Cisco, and we're in. Exit. All right, and you can go to any router, really. I can Telnet into any router because there is no username and password or anything like that. So what we're going to do, let's pick on the middle router. We're going to permit only its own subnet to Telnet into this router, but deny everybody else. And we see using a standard access list, which I said we couldn't because we can only use source addresses. All right, so what we're going to go ahead and do is we're going to permit or deny Telnet access, or we're going to permit Telnet access to this network, but we're going to deny these two access to Telnet into that router. All right, so let's go ahead and do that. Oh, Cisco, CISCO, enable, CISCO. All right, so config T, same thing, but this time we put a permit. Access list, let's say 2, permit the 192.168.101.0000255. So now I am permitting this particular network. I'm not going to put any other permit statement because then that wouldn't make any sense. So I'm going to let the implicit deny, the invisible deny, take care of everybody else. So where am I going to apply this? Well, I'm telnetting. So line BTY 0 space 15. I'm going to do access class. What number did I give it? 2. And then it's in, right? Because access class is the actual command instead of IP access group. It's access class. And then the number 2 is the access list number. And then in which direction? Well, we're trying to telnet in to the router. So we're going to deny any telnet connections. I'm going to hit enter. Do WR. And again, we do a show access list. and we can see it. But you can see show IP, let's say interface F00, that we haven't, let's maximize, that we haven't put anything there, and it's going to show the same thing on the other interfaces. So let's test out first this PC. This is the one that I'm permitting. I'm actually permitting. So I'm going to up arrow, Telnet. It lets me in, Cisco, CISCO, EN, CISCO. Lets me in. Okay, let's exit. So I can go ahead and Telnet from my own subnet. This is the one that I'm permitting. But can I do it from this subnet? I'm going to Telnet into the 101.254. Connection refused by remote host. Interesting. Let's go to this one. Up arrow, 101.254. Connection refused. Now, you're probably saying, you doubters, oh, you probably can't do that anyway. No, the access list is working, because if I wanted to, I can Telnet into the 100.254, and I'm in. There's no access list there. So I'm in router 1. So we have no username and password, so you can just go back and forth. Plain text, nothing. I mean, there's no passwords whatsoever. But that access list that we created, the difference was, instead of starting with a deny and then putting a permit any, we started with a permit only this particular network. And then we let the implicit, the invisible, the known, existing, deny everything to take care of the denying of everybody else. And then how we applied it. We didn't apply it to an actual interface. We applied it to the Telnet lines themselves. All Telnet lines that exist on that router. So nobody else can Telnet into that particular router, but the one I permitted, which was that particular subnet. See you outside the lab. Okay then. You saw that, right? We created a normal standard access list, which just states permit this time, access list, whatever, 1, permit this network or this host. And that's it. But where we applied it made the difference. We applied it to the Telnet lines, IP access class, the number of the access list, and the direction, which is in, because we're going into the router, because we're trying to Telnet into the router. And you saw that it worked perfectly. So you could use standard access list for certain things like this if you wanted to. So you don't have to waste a line when creating an extended access list just to block Telnet, when you can do it right there on the lines. Because remember, creating access lists doesn't mean anything, but they're still there on your router. So the more you have, the more space you're taking up on your NVRAM. Okay? Well, with that said, you saw how that standard access list worked, and it was the applying of the access list that made the difference using the IP access class command. I'll see you in the next one. Welcome back, everyone. Here we are, extended access list. That's what we're going to do now when we get inside the lab. Take a look at your topology. Take a look at it. This is what I mean that Cisco is making you think. All right, so I'm not going to give away anything. Let's go inside and get this done. All right, extended ACLs. So with extended ACLs, we know already that we can use source and destination IPs. We can use protocols such as TCP, IP, ICMP, IGMP, things of that nature, HTTP. Well, that'll be more of a port number. But you have more flexibility with an extended access list. Now, one of the things that you need to be careful when taking your exam is that if you look at this topology, you wouldn't have an issue, right? Let's say I tell you, all right, I want to block PC1 from accessing the finance server through web access. Okay, I don't want him to have web access to the finance server. So he can ping it, but I just want him to have web access. Okay, he can do anything else but web access. All right, and everybody else has all sorts of access to the finance server. On this topology wouldn't be an issue because you can follow what the book states. It says an extended access list is nearest the source, which would be right here. Because these are the two only, and this is the only enter point to this particular network. And then you get out. But what if you have some remote network? And let me see, let me put an actual WIC card. Oh, wait a minute. I want to make sure that this is, before I turn anything off, not hot swappable. All right, let me put a WIC 2T card in there. Oops. All right, so we can connect it to that cloud. And we turned it on already. Go to the CLI. Let's make sure everything's there. But we're going to have a connection there. All right, so one of the things that Cisco is doing, which is very good, it's making you think. So they're giving you not complex topologies, but they're giving you topologies that you say, well, where should I actually place this access list? It may not be what the book says. So let's say we can connect this. Let's use the good old lightning bolt here to take out all the guesswork for us. Awesome. All right, so now we have two entry points into this particular network. Now we may have an issue. Because if I'm telling you that this is the only PC, okay, I'm denying this PC and this PC only web access to this finance server, everybody else can ping. Oh, let's make it even better. Let's make it even better. I only want, let's make it even more stringent. I only want PC1 to have web access. How about that? I only want PC1 to have web access to the finance server. Nobody else can have web access to the finance server. But everybody can ping. Everybody can do anything else, but the only one that's allowed to have web access is PC1. Okay? So let's build that. And now you have to take in consideration that you have two entry points into this network. So you need to consider, where am I going to apply this? So let's do the access list first. Extended access list. Let's maximize this. Config T. Access list. 100 within the range. Permit host 192.168.1.2. I believe that's its IP address. I'm pretty sure it is. Yes, it is. Okay, so permit host 192.168.1.2 to host 1.1.1.1, which is the finance server. I'll use your wildcard mask since I already put the IP address. So you either put, oh no, I put host, didn't I? Okay, I didn't even see that. All right. So I'm doing access list 100, making it extended. I'm going to permit, oh, I forgot TCP. All right, this is the protocol that we're permitting, TCP. From this host to this host, source, destination, and then which port are we going to use? EQ80. So I'm permitting that. I am permitting that particular host to be able to access that finance server through port 80. But I'm going to deny everybody else. Access -list 100, deny TCP. Any means anybody to host 1.1.1.1 if they're trying to go through port 80. So I am permitting just that one host, denying all the other hosts port 80, and then the final line, access -list 100, will be a permit any permit TCP or permit IP, I should say, any suite, any source, any destination. So they can do anything else, any part of the IP suite protocol, any source, any destination address. Now, where do we apply it? That's the thing. That's where a lot of people get messed up because they're just reading the book and the book is saying, hey, an extended access list, since you're being very specific, you can do it at the source. But you need to consider that there's an entry point here. So if you apply it here, whoever's coming in through this cloud into this router, it's bypassing that particular access list. So you need to place it right here at the funnel in the out direction, because the packets are going to come in and then you just get them coming out. All right, so let's go ahead and do that. Let's get back on the router. And that's F00. So let's go interface, F0/0, IP access group 100. And it's going which direction? Out. Do WR. Okay. Let's see. Now this is the only one that's permitted. So let's give them a try. Port 80, our little handy dandy web server there, or web browser. 101.101, and I get the Cisco packet tracer. Awesome, that's the web page. Good to go. That's supposed to happen. But it ain't supposed to happen with nobody else. So if I do that here, I should get a request timeout. I should not be able to get to that finance server through port 80. Okay, request timeout. But can I ping it? Did I lose total connectivity to it? That's up arrow. No, I can still ping it. So my access list apparently is working. Let's try this now. 1.1.1.1. He should also get a request timeout. Request timeout. All right, and then can we ping it? Let's do an up arrow. Sure can. So our access list that we did is working, right? It's 3 lines permitting a particular host, denying everybody else to that host via that port number, and then permitting everything else from the IP suite to any source and any destination, most specific to most general. And again, it goes line by line by line, analyzing who is it that's trying to get out of this router, line by line by line. Once you make a match, then it stops. So definitely extended access list is a good way to go because you can be very specific in what you want to deny. You can deny port 80. You can deny port 23 for Telnet. You can deny port 22 if you don't want them to SSH. You can deny, remote desktop. You can deny all host of different things using your access list. Not to mention in a real world environment, you're going to have firewalls and you're going to create policies and you have Active Directory, that you have GPOs. So it's going to be a web of security that you're going to implement in your network. But for certification purposes, if you're asked to do something like this, think. Take a look at what the topology is saying and what they're trying to make you do. If they mention a port number or a protocol, that means you're doing an extended access list. If they're just saying, hey, deny this guy to over here, is a standard access list. Unless they say, hey, I want you to use a standard access list to prevent or deny Telnet. Well, then you got to do what we just did in the standard access list for Telnet, right? You apply it to the Telnet lines using the access class command. But this is an example of what you may see, something similar to that in your certification and maybe out there in the real world as well, all right? That you only want certain access through certain ports to a particular server and host. Okay, so there you go. That's your extended access list. Okay then, we're good to go. You saw how we went against the rules, didn't we? We created an extended access list that's supposed to be nearest the source, which is this is the source on this side, but we never applied it here. We applied it there. And the reason being, we have more than one entry point into the router. And I cannot drill that enough into your head. Now, the examinations, the certifications, they're holding a lot of weight, which is great because they're making you think now out of the box. Yes, you know the concepts. Yes, you know that an extended access list based on what the book says is nearest the source, but it all depends on the design of your network. Because if you were to place it here, like I explained in the lab, then when somebody from here is coming in, that will not get judged by that particular access list. It will just go on through. And the whole point was permitting web access to this particular web server from one PC. Everybody else is denied web access, and then they can ping or do anything else they want to the server, but they just can't have web access. But if they don't get critiqued by that access list because it's over here, they can do whatever they want. So you need to apply it at the funnel. That was the whole point of this particular lab, to think out of the box, not to contradict the book or anything like that, just to make you think. All right, and that's what Cisco's doing in their certs. See you in the next one. Welcome, everyone. Now we're going to do a named ACL. No big deal. The only difference here is instead of saying access list and a number, we need to say IP access list and a name. All right, so let's go ahead inside the lab and let's get it done. Named access list. Welcome, welcome. So that's one of the things now that they're testing you on, that if you know how to do a named access list. Not a big deal. Up to now, we're only doing numbered access lists. We say access list and then a number. Now to do the named access list, well, we just start a little bit differently. So let's go ahead and pick on this guy. And what we're going to do, we're going to do a standard named access list that's going to block 100, right? Well, not 100. Let's say 101, right? You have to do it nearest the destination. That's going to block 101 from accessing the 100 network. All right, so let's go ahead and do that. And it's going to be done through a named access list. So we're going to go config T. Well, let's see if there's any access lists on this router. No access list. Perfect. All right, so we're going to do config, and we're going to do IP access list. That's how you start it. So what do they want? Is it going to be an extended or standard? Well, I said I wanted to do a standard access list just for making it quick. Okay, standard. What now? You want a number or do you want a name? Well, no, I'm making a named access list. I want a name. So I'm going to block underscore 101 network. Okay, block 101. So now we're in standard named access list configuration mode. So what can we do here? Well, we want to deny. That's what we want to do. Well, what is it that we want to deny? Well, I want to deny the 192.168. Oops. 192.168. Okay. 68.101.0. Okay, now to give it a wildcard mask, I'm zooming. There we go, 255. There we go. Anything else? No, hit enter. Okay, so I'm denying that, but I need a permit statement, don't I? So I want to then permit any. That's it. That's what a standard access list is it not? You deny, and then your next line is you permit everybody else. So now we need to apply this. So we need to exit this. Now, nearest the destination, obviously, would be the F00. I'm pretty sure. F00, yes. And it's going to be out. So you know, interface F0/0. But now when we apply it, we got to use the name that we created, which was block underscore 101. So we go IP access group. What's the group? It's not a number anymore. It's block underscore 101. block underscore 101. In which direction? Out. All right, Control Z, WR. Let's do a show access list. And you can see it has standard IP access list block 101, meaning that is your named access list. And there it is. Deny this particular network, permit everything else. Okay, and then we go show IP interface F00. We see that we have an outgoing access list block 101, no longer a number. That's why it's called a name. So let's see if it actually works. So I shouldn't be able to ping, period. I shouldn't be able to ping that at all. I have no access to the 100 network. Ping 192.168.100.0. And look at that. Oh, it's coming back from the 10.115. Okay, so I didn't get to the 100. I said 100.0, didn't I? Yes, I did. All right, the 100.1. How about that? Destination unreachable. Either way, that was pretty cool because we did 0. And you see it said, no, you're getting a reply back from the 10.115, but whatever. It's 100.1, what we're trying to ping, and we're getting a destination unreachable, and that's what we want. So named access list is the same thing. It's a standard access list. The only difference, we didn't put a number, so they consider it a numbered access list. This is now a named access list, which is a little bit more descriptive, and it's easy for you to understand when you look at it. Oh, we're blocking this network. We're blocking this host. You can actually make it more human, right? So you can understand what that access list is actually doing just by the name that you gave it. All right, so there you go. That's your named access list. Okay, we got that done. No biggie. You can question your mark. You question mark your way through the whole thing if you wanted to. Now I do this so you can see what's available. What's really funny is that you can either do, when you do IP access list and you question mark, it says, do you want a number? Do you want a name? No, named, right? So we named it something. And it says, what do you want? Well, what type of access? Standard or extended? So it's still a standard or extended, but now when we apply it, we're applying it with the name that we gave it. And remember, no spaces. You got to have underscores. Or it can be descriptive, but you don't have to be that descriptive. That's why we have remarks now. Remarks. But either way, you saw that we did it. It worked. But you got to apply it correctly. If it's a standard or an extended to what you want it to do. And you saw that it went out without a hitch. All right. So there you go. That's how you create a named access list. See you in the next one. Welcome back once more. Now this looks like the same lab, but what we're going to do is create a remark. Yes, we're going to be even more descriptive than the named ACL. We're going to be very specific as to what this access list is doing. So let's not wait any longer. Let's get inside and get the lab done. All right, here we are in the remarks access list lab. All really it is, a remark, is to just make it even more descriptive so you know what this access list is doing. So this router doesn't have any access list, so that's why I'm picking it. So let's go ahead and do a simple access list. Access list. Access list 10, deny 192.168.102.1.000. Okay. Oh, I forgot one S. There we go. All right. So doing that, if you're within access list, if you do access -list, obviously you have the 10. Oops. You have the 10. You can now then make a remark, right? An entry, a comment, as it says there. So we're going to do a remark. And we can say, this is to block the 192.168.102.0 or .1 host. So you're very descriptive in what you're doing. Okay? So we made a remark, and now we need to do a permit statement. And you can make the remark first. You don't have to make the remark last. Access list or in the middle or whatever. Access list 10. It's just a comment. Access list 10 is not even going to be read. Access list 10. We hit deny, so we're going to permit any. Right? Do WR. And then we have to apply it to the interface F0/0. And then we go IP access group, and it's 10, and it's direction out, right? UWR. If you do a show access list, oh, you see the remark. I see a show. Is there a show remarks? No, of course not. Let's just do a show start. You'll see it there. It's a small configuration. All right, so Did I copy it? Am I not looking at it? There it is. And there's the remark right there that this is to block the 192.168.102 that host. That's it. That's all it is. You do your access list 10, and then once you reach that point, you make a question mark and you say, okay, I want to remark. And I mean, I put it second. You're going to put it first. You can put it last. It doesn't really matter. It's not going to get read because it's not blocking or doing anything. It's just a comment. So it's not even going to get read. This is for you to understand what this access list is doing. Okay? That is it. That is it. Just like a named access list. So imagine you can create a named access list and then create a remark on top of that too. So you can make it even more descriptive to do so, because you could do, and even though I applied it, it doesn't really matter. Config, I can apply it to the other interface I want to. I don't have to apply it at all. It can just be sitting there. You can do an IP access -list. And again, what are you doing? Oh, I'm doing a standard. Okay, well, it's called block the boss. Oh, okay, no spaces, underscores. Block the boss. Okay, so I'm blocking the boss. So, but if you're there, look at your remark right there. Look at your remarks right there. So I can make a remark, or you can say, oops, well, yeah, you're in status, you will remark, and you say, I don't like my boss in my computer. Okay, you shouldn't need underscores there because this is a comment. Doesn't even get read. And then it's okay, we're going to block the boss because you don't like him. Okay, so we're going to deny the boss, whatever, 1.1.1.1. All right, and then 0.0.0.0. We're going to deny him, and we're going to permit everybody else. Control Z, WR, oops, Control Shift 6, WR, and then let's do a show start. And where she blows, there she is right there. So you have an IP access list named block the boss, which the remark means I don't like my boss in my computer. And then you deny that particular host and you permit everybody else. So it's even more descriptive. That's all it is. It's a comment. It's a remark. No need to overkill that. I'll see you guys outside the lab. Okay, we did the overkill remark, right? But we did it within a named access list. As you can see, IP access list, standard, block underscore the block underscore boss, because we can't put no spaces there. So we're blocking the boss. But on top of that, we made a remark and we said, I don't like my boss in my computer. And you saw it let me do it without underscores. You're very descriptive, you know, telling everybody exactly what this access list is doing and why you want it done. All right, but since this is a remark, it's not going to be read, so it doesn't really matter. This is something for you. So when you look at it, you do the show access list command, you can actually see what it is. And then we deny the host, which doesn't even really exist, and then the permit everybody else, because we denied and then we permit. All right, so we did follow the rules, but just to tell you that, you know, it's an overkill. You know, there's a named access list, block the boss, and then you're giving a reason, you're making a comment. So that's all a remark is. It's a comment in an access list, standard or extended or named, that you can be more descriptive, so you can know exactly what it is that you're doing. Now, obviously, I'm making fun here, but this is something that's new that they brought in. So you may be asked, I don't know, you may be asked to actually create a remark, and that's how you do it. See you in the next one. Okay, we made it to the summary of the section. We're done with access lists for the time being. We learned the rules of access lists, one access list per protocol, per direction, per interface. We saw the standard access list, the benefits, right? Because we can use it for Telnet. It allows us with the IP access class command. But again, not so good because you have to put it in the destination, create it and apply it in the destination only using source addresses. So that has its pros and its cons. And that's for the Telnet and the standard, both standards. Now, extended, very flexible, very flexible. Okay, we can use source and destination addresses, protocols, and port numbers. So we can place it nearest the source. But what do we learn in that particular lesson? That you have to look at your topology. You have to look at your topology. Okay, because if not, you may apply, you may do it correctly. And this is for you that are taking the certification. You may create the access list exactly how they want it. If you apply it in the wrong interface, it's wrong. So look at your topology so everybody knows. So you know that you have to apply in the correct place. Named access list. Well, instead of giving it a number, you gave it a name. We just saw that. And remarks, we just finished seeing that. It's just a little bit more descriptive than the actual name that you gave the access list. I guess you're giving them the reason why you're doing it. All right. But this is all about your ACLs. Very simple. Nothing out of this world. And that's it. See you in the next.